Hi everyone, so today I'll be starting with impression material. This is a whole unit in itself, so I'll probably cover this in 2 lectures. And if to give you an overview, we'll first talk about the definition, the ideal properties of impression material. Then there are mainly these 5 categories that we have to study. So first is impression compound, second is ZOE paste, third is agar, fourth is alginate, and fifth is elastomer. Elastomers has its own categories. So today I'll cover up to agar, and then in the next lecture we'll go over alginate and elastomers. Okay. So for each impression material, we have to talk about the introduction, the mode of supply, application, composition, setting reaction if applicable, properties and advantages and disadvantages. Okay. So first starting with the definition. So dental impression, you have to talk about the definition of impression first. Okay. So dental impression, it is a negative record of the tissue of mouth. Okay. So whatever is in the mouth, it is so we have like positive, positive structure is your mouth. Then we take negative record, that is the tissue of mouth, and then we make a positive replica. So that is the gypsum product. So this is a negative record of the tissue of the mouth that is used to register or reproduce the form and relationship of teeth and surrounding tissue, and it is used to produce a positive cast. So your mouth is there, and then we have a negative replica, that is your impression, and then we form a positive cast out of it. Okay, so we pour gypsum in our impression and we form a positive cast out of it. So this is the a whole explanation of the definition. Okay, so talking about the ideal properties of impression materials, what properties do we want when we have an impression material? Okay, ideal properties that are required. So first we want it to have a pleasant taste, odor and aesthetics, because we are putting something in your patient's mouth. So we want it to taste good and look good. Okay, we don't want it to be repulsive. Then it should not contain any toxic or irritating ingredients. Okay, it should have a good shelf life and setting characteristics. So the setting time should be just adequate to be used in a clinic. Okay, it should be easy to manipulate and with minimum use of equipment. So we don't want a very complicated process. It should have satisfactory consistency for use in clinics. Okay, adequate strength. So we want various type of mechanical properties. Strength and dimensional stabilities are two important qualities that we want in our impression material. Right, by dimensional stability, like it shouldn't change its dimension over a range of temperature or humidity. And by strength, we mean that it shouldn't tear up or fracture, right? Then it should be compatible with dye and basically gypsum product, and it should be electroplated. So what we do, if you don't already know, we have a tooth, right? And we pour an impression material over it. You would have done this in first year. So you put like an impression compound or something over it, and then you form this replica, right? And then you will pour gypsum in it to form a positive cast. So we want a material that should be compatible with gypsum. Okay, and it should be electroplatable, right? Most materials aren't, but it is a quality that we desire, right? Then talking about, it should not go any permanent deformation. So it is again about the dimensional stability thing, and it should reproduce accurate details. So the more and the better accurate reproduction of details of the surface we have, the better the material is. Okay, so these are the ideal properties. Now talking about the classification. So so there are 3 bases of classifications. Okay, first is based on the mode of setting, second is the based on tissue displacement, and third is based on elasticity. So the elasticity one is the easiest one. I'll go over this first and then I'll go over the other two. So talking about the elasticity, so first we have 2 categories. One is rigid and one is elastic. So we all know what rigid means and what elastic means, right? So in the rigid category, we have impression plaster, impression compound, waxes, and ZOE paste. Okay. So these are the ones that are rigid. Now coming to elastic, we have 2 categories again. Again, we have hydrocolloids and non-aqueous hydro or non-hydrocolloids or elastomers. Okay. So hydrocolloids, they have water content in them. So we have agar and alginate under hydrocolloids. Okay, and the non-water containing ones, the elastomers, we have polysulfides, silicones, polyethers. Okay, and then silicones have addition and condensation categories. So this is the basic classification. Okay, so just remember that we have a rigid category and we have elastic category. In elastic category, we have aqueous and non-aqueous. In aqueous, we have agar and alginate, and in non-aqueous, we have elastomers. Okay. Now, this is based on elasticity and rigidity. Now, if I go back to the other classifications, here I have one classification based on the mode of setting. Okay, so how it sets. There are two modes of setting. First is by physical change, and second is by chemical change. So the one by physical change or temperature change, this is reversible. Okay. And by chemical change, it is irreversible. Right. So the ones that set by physical change, they are called thermoset. Right. Because, sorry, they are the ones that set by chemical change are called thermoset because they are irreversible. So you can remember like set as in irreversible. And the ones that set by physical change are reversible or thermoplastic. Okay, so now which ones set by uh, which ones are which materials are setting by temperature change or physical change, right? So we have four materials. First is impression plaster, second is ZOE paste, third is alginate, and fourth is elastomers. Okay, now here we have two categories. We have divided into two. So we already talked about the rigid and the elastic materials over here, right? We talked about how impression plaster and waxes and ZOE paste are rigid materials, and alginate and elastomers are elastic materials. So just instead of placing all the four into one category, we divided into rigid and elastic materials. Okay, so the rigid ones are impression plaster in ZOE paste, and then we have elastic materials that's set by chemical reaction, that is alginate and elastomers. Now, the impression materials which set by temperature change or chemical reaction, by physical reaction, we have impression compound because we have used it. This is reversible. It sets by heat. Okay, and then we have impression wax. So just waxes. They also change this physical form on applying heat. And then we have agar. So agar sets by physical reaction. So if you look over here, you will see, if I go to this classification again, you will see that we have ZOE, this is setting by chemical change. Okay, we have impression plaster, this is setting by chemical change. We have alginate, this is setting by chemical change. And we have this entire elastomers, these are setting by chemical change. And all the others, they are setting by physical change. Okay, now the third basis of classification, it is based on tissue displacement. So when you place your impression material on your oral in your oral cavity or on the tissue, so if it compresses the tissue or displaces the tissue, this is called mucocompressive, and if it does not compress the tissue, it is called mucostatic. So which ones come under mucocompressive? So we have impression compound and high viscosity alginate that comes under mucocompressive. So this will compress the tissue. It is not ideal, right? And then under mucostatic, we have impression plaster. So they won't compress the tissue. We have low viscosity alginate and ZOE paste. Okay. Also another thing, when we are talking about rigid and elastic material, so remember that the rigid material, it is used to take impression of edentulous arches. Okay, so the arches without teeth, and the elastic material, it is used for dentulous arches, okay, with teeth. So this is where it is used, right? Now coming to our first category, so I told you we'll be studying um, these all of these impression materials, right? So we'll be studying all of this, and for now the first impression material we are studying is impression compound, right? So starting with impression compound, just a second. So it is also called modeling plastic. It is rigid, irreversible, and mucocompressive. We already saw that. Okay. Now coming to its classification. So we have two categories. We have type A and type 2. Type A is it is the tray compound. Sorry, it is like the cake compound, right? And this is a tray compound. Type A is low fusing, so it has lower fusion temperature, and type 2 is higher fusing. It has higher fusion temperature. Now it comes in two forms like sheet and stick. So over here you can see you have like not sheet, it should be actually cakes. So cakes and stick, and this comes in like cube kind of format, right? So it is used to prepare impression trays. And here in cakes and sticks, so cakes are used to take impression of edentulous arches. We have already used this. And sticks are used to take impression of like a single crown, and it is called copper ring technique or tube impression. Okay, so it is also used for border molding. Okay, and so these are the two categories we have. Now talking about the mode of supply, so we have sheets, sticks, cakes, and cones. These are the forms in which we can get it from the manufacturer. Now talking about the application, so it is used for taking primary impression. We know that we have used it again, and then it can be used to take individual tooth impression. So we talked about this tube impression thing, right? Then it is used for border molding. So we already talked about this as well, and it can be used to check undercuts and inlay preparation. Now moving ahead, talking about the composition. So this is generally the difficult part to remember. So I'll go over it in a diagrammatic format. Remember you have this, whatever this cake or compound is, right? I'll use a different color. So you have this cake or compound. Now you know that first of all this has a thermosetting thing, right? Something that is waxy or um, which will change its properties on application of temperature, right? So that material, it is resin, and it is called copal resin, right? So this would be your main material, and this is for thermoplasticity. But you would notice that it is only 20%. So we would want another major component. What else is making the major bulk of this thing? Okay, so that is your diatomaceous earth, and that is your filler kind of, right? So your filler is making major bulk other than your thermoplastic material. So these are the two major compounds you can remember. Zoom out a bit. So first is resin and second is your filler. Now what else do you want in your compound? You want a plasticizer. A plasticizer is always present. A coloring compound is always present. And then in this case we want a smooth surface. So for that we have a wax, right? So we have 5 components. If you go over it again, I have a cake of impression material. So my first basic component is the resin, copal resin, but it is only 20%. Then something else forming the major bulk of it. It is the filler, right? And the filler is diatomaceous earth. So it is 50%. Then I have something else providing it color. So I'll have some coloring compounds. I'll always have a plasticizer. So the plasticizer is stearic acid, right? And that is 3%. And then I'll have some coloring. I've already talked about the coloring compound, and I'll have something to provide it a smooth finish. So that would be waxes, and wax is only 7%, right? So this is a way you could try to remember the composition and the function. Now, talking about the setting reaction, so it is a physical setting reaction. There is nothing special. We have a rigid compound. We heat it, it gets soft, and then when we cool it, it gets rigid again. This is the entire setting reaction. There is no chemical reaction going on. Now, talking about the properties. So, first, biological properties. It is non-toxic, non-poisonous, not non-irritant. Second is the flow. So, we have two types. Remember, type 1 and type 2. So, the type 1 has a higher flow in mouth temperature, right, and at 45 degrees. So, this has a flow of 6% and mouth temperature and 80 to 85% at 45 degrees. And the type 2 one, it is the harder one, okay, so it has a flow of 2% at mouth temperature and a flow of 70 to 85% at 45 degrees, right? Now talking about the factors affecting flow. So there are only two factors. First is wet kneading. So this will affect flow, and there is high temperature. So but what the problem is with wet kneading is that it can cause entrapment of air and water in the dough while we are kneading it, and which disrupts the properties. Okay, it can cause like permanent deformation. And then we have high temperature. So when we put it in water bath, remember, so like your plasticizer will leach out into the water. It will basically drain out into the water, and that will affect the physical properties of your impression compound. So that is not ideal as well. Okay, talking about the thermal properties. So we have a glass transition temperature of 39 degrees. Now what is the glass transition temperature? So if I cool it from 39 degrees any further, it will um, fracture. Okay, it will not fracture, but it will um, lose its brittleness. Right. So basically, this is the temperature of this is a transition temperature. Above this temperature, if I heat it, it will not be brittle. It will get soft. Okay. And if I cool it any further, it will lose the brittleness. Right. It will lose the rigidity. So this is the temperature where you can say that below this it is solid, and above this is flowable or moldable, or not liquid but moldable. Okay, but talking about the fusion temperature, so it is 43.5 degrees, and this is the temperature at which the compound is moldable. Okay, so this is the fusion temperature. Now talking about the coefficient of thermal expansion, so it is pretty high, not very ideal. It is 0.3%. Um, so the compression that takes place between mouth and room temperature, so it will shrink by 0.3%. Okay, so not very ideal. To reduce this, what we can do is we can take a primary impression, then put it over a flame, and then again take a secondary impression, so that will reduce the shrinkage. Okay, or we can spray water on tray before loading it. Okay, so we have a tray, we spray water on it, and then we put the impression compound, we load it over it. So what will happen, that the part touching the tray, it will cool down first, and it won't go on deformation as much. Okay, now talking about the thermal conductivity, so it is very low. Okay, and therefore careful handling is required. Now talking about the distortion, so some distortion obviously occurs in impression compounds, and what are the factors contributing to it? So it has a very high coefficient of thermal expansion, poor thermal conductivity, and the temperature drop. So we have mouth temperature and room temperature. So all these three factors, they contribute to the distortion of impression compounds. Now talking about the advantages and disadvantages. So the major advantage is it can be reused for the same patient. Okay, it is correctable. So if I like missed a spot, I can put it again and press it over there, and it can be extended beyond the tray borders, so it can support itself. Okay, so there are no extra adhesives required, and even if it flows outside the tray material, we don't need anything to support it, so it can support itself. Now talking about the disadvantages, so it has a very high viscosity. Okay, so it compresses the tissue, and it does not record the details accurately. Okay, it compresses the soft tissue. It does not reproduce fine details. Again, the same thing. And it has distortion. It shows undergoes distortion. It has poor dimensional stability. Okay, now talking about the manipulation, so we know how we manipulate it. If we have a stick, we heat it directly over a flame, or if we have a cake, we put it in a water bath, right? Then we knead it with fingers to like distribute the heat throughout. We load it on a tray. We place it in the mouth or oral cavity. We record the impression, and we forecast within an hour. Okay. So we are done with the first topic, that is impression compound. Now we'll go over the second topic, that is ZOE paste. Now remember, ZOE paste is also a rigid compound. Okay, so this is also supposed to be used for edentulous arches, right? But it has good recording properties. It can record good surface details. So ZOE when mixed with eugenol produces a hard mass which has wide application. So basically we have zinc oxide, and when it is mixed with eugenol it produces a hard mass, and we use as this property as the impression, like for taking impression. Now talking about application where it is used. So it is used as a corrective impression. Mm, just a second. It is used to take corrective impression or final wash. Yep. So it is used to take corrective impression or final wash. So what that means is, corrective impression is like if I have taken this impression. So this blue part you see, this is my primary impression. And to record more surface details, or like if I have missed out something, I will take this blue impression first. And this brown thing you can see, this would be the ZOE. I will pour it over my first impression, and then I will take a secondary impression. So this is called the wash impression or corrective impression. Okay, it is also used as a bite registration paste. It is used as a temporary relining material for dentures, and it is also used as a surgical packing material. Okay, so these are the four applications. Talking about the mode of supply, so it comes in a two-paste system. We have two tubes. One is the base paste, which is white in color, and second is the accelerator paste, which is red in color. Okay. Now talking about the classification, so it is according to the ADA specification 16. We have two types. We have type 1, which is fast set, and type 2, which is normal set. Now the fast set one has thin consistency and normal set one has thick consistency. Talking about the composition, so again we have two components, right? We have this base paste and we have catalyst. So talking about the base paste first, which is white in color, we have zinc oxide. So this is our basic main ingredient. Okay, we have vegetable oil, which acts as a plasticizer. We always have a plasticizer in almost every compound. And then we have calcium chloride, which acts as a retarder. So it prevents the reaction from starting too quickly. Okay, so we have ZNO, we have which is 87%. So this also forms the major bulk. Then we always have a plasticizer. So remember, we have vegetable oil as the plasticizer, and then we have a retarder, that is calcium chloride. Now coming to the accelerator paste, right? So imagine you have a paste. Now what would be the first compound in it? I told you that when zinc oxide reacts with eugenol, it forms the hard mass. So we already had the zinc oxide in our base paste. Now of course we would want eugenol. So that would be our basic compound. Okay. So it is only 12% though. It is the reactive ingredient. Now remember, in every compound we have a plasticizer and a filler, in this case, in most cases as well. Okay. So remember, we have a filler that would form the basic, that would also form a bulk of a substance. Okay, so we have silica as the filler, and it gives strength and body. Okay, now we have a plasticizer as well. Plasticizer, what it does is it binds everything together. So we have lanolin as the plasticizer. It is 3%, right? Now, or again, we have now till now we have talked about the three compounds, but still we don't have the compound that makes the bulk of the paste. So if you look here, you have gum damar or polymerized resin, 50%. It provides thermoplasticity and it forms the bulk of the compound. So this is 50% in itself. Okay, and then we have an accelerator, that is calcium or magnesium chloride. Okay, we have resinous balsam, which increases the flow of it, and we have a coloring compound always. So remember, we have seven compounds. So the base paste is easy to remember, right? We have only three compounds. But in the accelerator paste, we have seven compounds, and if you go over it again, so first we have obviously the major compound, the basic, that is the eugenol. Then we will always have a plasticizer. So in this case, the plasticizer is lanolin. We will always have fillers. So the filler is silica, and it gives strength and body. So that is 20%. Now talking about another thing forming the thermoplasticity and bulk of the compound. So we have polymerized resin, which is 50%. So these are four of the major compounds. Now talking about the minor compounds, we have an accelerator, so that is magnesium or calcium chloride. We have coloring agents, okay, and then we have covered everything, I think. Yes. So that no, we have resinous balsam, so that increases the flow. So remember, we have four major compounds and three minor compounds. Okay, so this will make it easier for you to remember this. Now talking about the setting reaction. So what happens is, first zinc oxide will react with water and it will form zinc hydroxide. So this is called hydrolysis. So the first reaction is hydrolysis, and the second reaction, it is an acid-base reaction. So the zinc hydroxide, which is a base, it will react with eugenol, which is an acid, to form zinc eugenolate. Okay, so this is the salt that is formed, and we have water, of course. So this salt, it has chelate form. Okay, so it forms a chelate. So a chelate is something that has like various bonds and everything, and they crystallize together to form a sigma. So these are the chelates that are formed by zinc eugenolate, and they crystallize together. And this water that is formed, it helps in binding these. So this water, it will help in binding of these chelates. Okay, so this is the setting reaction of zinc eugenol paste. Talking about the setting time, so the initial setting time is 3 to 5 minutes, and the final time may be up to 15 minutes. Okay, so remember, it has to be seated in your mouth before the initial setting time, so your working time would be approx 5 minutes, right? Not more than that. Talking about the factors affecting setting time, so these are mainly the factors that a dentist can't control. Okay, so the size of zinc oxide, base accelerator ratio. uh, so you always take base and accelerator in 1 to 1 ratio. Then retarders, so how much wax and everything is present in there. So these factors aren't under the dentist control. All you can control is the mixing time. Talking about the properties, so consistency and flow, it is a mucostatic material, so it does not displaces the soft tissue of your mouth. Okay, and it produces finer details. So remember, in the impression compound, we did not have very fine details. Over here we can reproduce fine details. Okay, talking about the spread, so the type 1, the thinner one, it has a spread of 30 to 30 to 50 mm, and type 2, the thicker one, it has a spread of 20 to 45 mm. Okay, compressive stress, so it has a compressive stress of 7 megapascal, and it resists fractures. Okay, dimensional stability, it is better than the impression compound. It has a negligible shrinkage of 0.1%. If you remember, the impression compound that had a poor dimensional stability. Okay, so it is compatible with stone and dye, so compatible with gypsum. Basically, the shelf life is nice, it is of 1 year. Now talking about the manipulation, so you take the base paste, just a second, so you take the base paste, it is white in color, and then you take the accelerator, which is red. I'm just making it pink, right? So this is the accelerator, and you would mix it using a stainless steel spatula on a glass slab. Okay, make sure you don't have any oil or waxes on the glass slab. Okay, it is an exothermic reaction. Remember, the setting reaction, it is an exothermic reaction, so you can even cool the glass slab and the spatula to reduce the setting time. Okay, the mixing time is 1 minute. You should have a uniform color all over the paste. Okay, and then it is loaded on a custom tray or special impression tray. You, after taking the impression, you disinfect it and you can pour cast over it. Now talking about the advantages and disadvantages of zinc oxide paste. So first major advantage is that it records accurate details. Second is that it is dimensionally stable. These are mainly compared to the impression compound. Okay, and they do not require a separating media for loading. You can directly load it on the custom impression. Okay, and minor defects can be corrected locally. Now talking about the disadvantages, so it requires special tray. It's not like you can put it in a steel tray and take impression. It requires special custom trays. Okay, it is of sticky nature, so it sticks to the tissue. It can cause burning sensation in some people due to ethanol, and it can cause tissue irritation, and it can be used for teeth and undercut areas, and it is inelastic in nature. Okay, so talking about this should be actually in the um, advantages section. This is not a disadvantage. Okay, now talking about the elastic impression material. So if I go back to the classification, in the non-elastic ones, we will only be talking about um, impression, sorry, we will only be talking about ZOE paste and impression, not plaster, impression compound in this chapter, in this unit. Okay, we'll talk about waxes and um, uh, why did I highlight plaster? We will talk about waxes and plaster in another lectures. We have separate chapters on that. So now we have completed the inelastic, the rigid material. Now we will move on to the elastic material. And first, I'm going over the hydrocolloids. So I'll talk about agar, up to agar in this video, and I'll cover alginate and the elastomers in the next video. Now coming to agar. So elastic impression materials. So these are colloid. Just talk about colloid first. Okay, colloid is because we're talking about hydrocolloids, right? So what is colloid? It is a fourth state of matter. Okay, so it is not solid, it is not liquid, it is not gas. It is when one substance is very homogeneously mixed into another substance like a sugar solution. So that is a colloid, right? We have a dispersed phase and we have a dispersion phase. We already know that. Now we have two forms of a colloid. One is a sol, one is a gel. So a sol is like a liquid, sort of a viscous liquid, and a gel is like solid, not exactly solid, but a semi-solid, like jelly-like structure. Okay. So how we take impression using elastic impression compounds is we have this viscous liquid-like substance, and we make it undergo gelation, and then it forms the gel and it will record the impression, right? Now it can undergo gelation by two processes. One is through temperature change, which is what agar does. So we cool it down, we have a sol, we cool it down and it forms the gel. And second is through chemical change, so which is alginate. Okay, so it will react and it will form a gel. Now talking about agar, so this is our first hydrocolloid. So it basically it is also called dentacol. Okay, these are all the other information. It is extracted from a seaweed and it is sulfuric ester of linear polymer of galactose. Okay, so just remember sulfuric ester of and linear polymer of galactose. Okay, it is called reversible hydrocolloid because it sets by physical reaction and it is reversible. So it has, remember the sol and the gel. So the sol is like a liquid and gel is like a solid. So it can transition between the solid and the liquid depending on the temperature. Okay. Now talking about the classification. So it has four classes based on its consistency. So first is the heavy body, second is the medium body, third is the light body, and third A is the light body for laminate technique. So I'll talk about the laminate technique. Uses, it is used to take impression of dentulous arches, so means with mouth with teeth. So it is used to take impression of mouth with teeth. Okay, it is used for for what, for making what? So it is used for making crowns and bridges. Okay, partial dentures, duplicating materials, and tissue conditioners. Okay, tissue conditioner should be over here, right? Now talking about the mode of supply. So it comes in two formats. We have a tray material and we have a syringe material. Okay. So the tray material, it comes as a gel in a tube basically, and the syringe material, it comes in various small cylinders. Okay, so various small syringes. Now talking about also the syringe material, it is more fluid. Okay, so it is used for the laminate technique and it is more fluid, and I'll show you why when we talk about the laminate technique. Now again coming to the composition of agar, right? So how many materials do we have? We have 1, 2, 3, 4, 5, 6, 7 and 8. We have 8 material. Now talking about the basic component. First, of course, we're talking about agar. So we will have agar. It is the gelling agent, the basic component, the gelling agent. But you would notice that it is only 13 to 17%. So there is something else that is forming the bulk of the entire gel. So that is water. Water is 84%. Okay, and this is the dispersion medium. So I talked about the dispersion medium. This is the dispersion medium, that is 84%. So these are the two major constituents. Now talking about the minor constituents. So again, we will always have some filler and a plasticizer. So over here you will see that the filler, it is diatomous earth again, and we have a plasticizer, that is sextostropic material, glycerine and thymol. Okay, so we always have a filler and we always have a plasticizer, and for the sake of simplicity, you can mention them both to be 0.5%. Okay, now we have a retarder. Okay, and not retarder, sorry, we have borates, which act as retarder for the gypsum and which is not desirable. Its main property is to add body to the powder or to the gel. Okay, so it increases the body, but what it also does, it when we pour cast over our impression, it retards the setting of gypsum, so we don't want that. Okay, so this is the compound borates adds more body, it gives strength to the gel, but it also retards the setting of gypsum. So to overcome that retarding effect, we have potassium sulfate. Okay, so it increases the setting of gypsum. So it decreases the setting time, increases the setting reaction of gypsum to overcome that effect. And then, as always, we have some coloring and flavoring agents because it's impression compounds. And we have alkyl benzoates, which is a preservative. So if you go over it once again, just to revise, we have eight components. Okay, so the first, we obviously have agar. It is the gelling agent. Then the bulk that is formed by water, that is the dispersion medium, right? It is 84%. Then we always have a filler and we always have a plasticizer. Okay, we have a borates to give more body to the compound. Okay, we have potassium sulfate to overcome the retarding effect that is caused by the borates. Okay, we have coloring compounds, and we have a preservative, that is alkyl benzoate. Okay, now coming to the properties. First, that is flow. Okay, so we want a good flow to record finer details, and this has good flow. It records very fine details. Actually, agar records better details than alginate, but we don't use agar as much because it has a difficult manipulation. Okay, gelation temperature. So ideally, it should be between 37 and 45 degrees, and this gel sat between 32 to 40 degrees, which is ideal. Okay, so and flexibility. So ideal is 11%, and this has 4 to 15%, which is also good. But although it is flexible, it does not completely recover from being deformed during removal. Okay, so it shows some deformation during removal, which is not ideal. Okay, it is highly elastic, and the elastic recovery is 98.8%, so which is again a good property. Reproduction limit of 25 micrometer, so it is about the reproduction details, which is good. Okay, again accurate reproduction of details, but again a very major problem with hydrocolloids, both agar and alginate, they undergo something called synersis and imbibition. So basically it is that they lose water in a dry environment, and they can absorb water when put back into water. We'll discuss this in detail. So because of this, they are dimensionally unstable. Both agar and alginate, both of them have this problem. So they are dimensionally unstable. Okay, the working time is 7 to 15 minutes. The setting time is around 5 minutes, the initial setting time. Okay, and it can be controlled by regulating the flow of water through cooling tubes. So why I'm saying this, we'll talk about this in the manipulation. Okay, the tear strength is not good, it is weak, it has weak tear strength. Okay, now talking about the manipulation, so I'll talk about all that water and stuff. So what happens is, in the manipulation there are two steps. First we need a hydrocolloid conditioner for storing this, for storing agar. So what happens is, the agar will come in a gel format. Okay, so let's say this is my gel format, this is a solid. Okay, it will come in a gel format. I will put it into the boiling section at 100 degrees. Over here it will be converted into a salt, so kind of a liquid. Okay, so now it is boiling. I can't put this in the patient's mouth, it is very hot, so I'll put it in the storage section. Over here it can be stored for up to 3 days, and the temperature is 65 to 85 degrees, so it is still in the sol condition. Okay, now I know that a patient has come to me, I want to take the impression. Okay, so I will put it in the tempering section at 46 degrees for up to 2 minutes, and I will take this out in a tray. So I will have this impression tray. I will take my material out at 65 degrees and put it in this tray, load this tray with the material, and I'll put it at 46 degrees. So it is still salt, but it can be put in a patient's mouth. I can't put something above 46, 47 degrees in a patient's mouth. It will be too hot, okay, too hot for the oral cavity. So it cools this tempering section cools the material so that it can be inserted into the oral cavity. So first we want all this set up, the hydrocolloid conditioner for using agar, which is not very ideal. Okay, we want something that can be easily like taken out of a tube and put it into a tray, okay, and take impression. Then the second thing we want, the trays we are using, these are not normal trays, these are rim lock trays. Okay, so these trays, they will have a structure kind of like a box. So let's just say this is my tray, right? And it will have this vertical extensions, and so if I take a cross section, which is very hard to draw, so it will be like this, and it will have vertical walls as well. Okay, so vertical walls over here and over here, right? So these are called rim lock trays. You can Google the image. I should have put it into here. Okay, and then these trays have water inlets and outlets. Okay, so these trays have tubes running around it, water tubes inside it, and water runs across it so that it cools the agar for its setting. Okay, so there will be water running inside it like a canal, and it will cool the agar for its setting. So obviously it is expensive. So this is why agar is not used so much, because it has all the good properties, but it is so difficult and expensive to use. So we have this tray where we have a space of 3 mm. So this is a tray, right? So we want a space of 3 mm occlusally and laterally, right? And then there is water running through it at 13 degrees. So the water will be running at 13 degrees. We put this tray in the patient's mouth. The tray containing the tempered material is removed from the bath. The top layer is scraped off. Okay, we put it, the water hose is connected. So remember, there is a water hose that is connected to the tray. We connect it after loading the material, and then water is circulated at 13 degrees to cool the tray so that the agar can set. Okay, remember, agar sets by physical reaction by cooling the liquid, the salt, to convert it from salt to gel. Now talking about the laminate technique. Okay, what happens in the laminate technique? I have this tooth. Okay, I have this tooth. I want good reproduction of details, but I want to use agar. So I will use the syringe material. I will directly put the syringe material over my tooth. Okay, over here. And what will I do? I will load a tray, a normal tray with alginate. Okay, with chilled alginate, so cool alginate, and I will put that tray over this compound again, right? So what this will do is, so I will record good details because on the tooth surface I have agar, but I do not require that water cool tray. So I should have removed this from here. This should not be over here. I don't require the water cool tray and all that container, and I will need the container, but not the water cool tray. Why? Because this agar, this sets by, this is the agar and this is the alginate. So the alginate will set by chemical reaction. Okay, so I don't need any temperature change to make it set. And since the alginate is chilled, this agar will set by the lower temperature, by the temperature of the alginate. Okay, so I don't need at least the rim lock trace. So this is the laminate technique. It produces accurate details, and you don't need so much like tray and equipment. So the advantages of the laminate technique, it is low cost because we don't need the water cool trays. Right, water cool trays are not required. We need less preparation time, and it records all the finer details. Okay, so if we were using just alginate, we wouldn't be able to record so many details. Now it has poor dimensional stability. Agar alginate bond is not always strong. So while removing the impression, my impression may not completely come off, and the agar may just like stuck to the teeth. Okay, so that is a problem. And viscous alginate may displace the agar during seating. So it is also possible that while I am putting the alginate over the agar, the alginate might just come over here, okay, and displace the agar from here. So these are some of the disadvantages we might face. Now talking about the advantages and disadvantages of this entire agar in general. So it produces accurate dyes, so accurate reproduction of details, good elastic properties. Okay, so it can reproduce undercut areas easily, good recovery from distortion. So does not it has good elastic recovery. Okay, 98.8%. So good recovery from distortion. It is hydrophilic, so good for oral environment. Okay, palatable. It can be used as a tissue conditioner as well. It is economic, and it can be used for duplicating models. Now talking about the disadvantages, so it does not flow very well. We could do some better flow material. Okay, it cannot be electroplated, which is a major disadvantage. It may be painful during insertion because it could be hot. Okay, so the temperature change thing, it could be painful during insertion. It tears easily, so it has a very bad tear strength. Only one model can be poured at a time, so we want an impression material through which we can pour multiple models at one time. So only one model can be poured, and it is very expensive and extensive to use, so we have a lot of steps and we require a lot of equipment, so which is a major disadvantage. That's why we don't use it, and it is difficult to sterilize. Okay, and so this is it for this lecture. I'll continue with alginate and elastomers in the next part. Okay, thank you.